Water hemp is classified by growers as the most important weed control challenge. So obviously we're emphasizing water hemp control in sugar beets, and that's the basis for this project that I'm gonna talk to you about. So the current water hemp control program utilizes a pre-emergence herbicide followed by a split application of chloroacetamide herbicides. Generally, these applications are made before water hemp germinates and emerges, usually at the 2-leaf sugar beet stage and then again at the 6-leaf sugar beet stage. The use of these chloroacetamide herbicides is widely adapted by more than 90% of sugar beet growers for water hemp control. However, there are environments where water hemp control does not reach 80% control, and additional methods are required to achieve acceptable control. So in previous years, desmetafam and fenmetafam were used in a premix called Betamix for post-emergence control of broadleaf weeds, including water hemp. However, Betamix obviously not being re-registered and inventories are rapidly dwindling, then we throw in glyphosate, ethylfumicate, and upbeat resistance issues. So that has marginalized efficacy against water hemp. So as Jared was saying, in-row cultivation, hand weeding are remaining control options. And then the hooded sprayer research as well. And while these are good options, there is still a need to develop a post-emergence herbicide strategy to complement this mechanical control. So previous research had indicated crop tolerance of sugar beet to acifluorfen. Acifluorfen is a contact herbicide that's currently used in soybeans for post-emergence control of annual weeds. It would not be a standalone program in sugar beet, but rather it would provide growers a post-emergence option. UPL acquired Acifluorfen in 2003, and it markets it with the trade name of Ultra Blazer. We've been working very closely with UPL, and they are extremely motivated to get Ultra Blazer registered in the sugar beet market. So we conducted experiments this past summer with multiple objectives. The first objective was to evaluate sugar beet tolerance. A randomized complete block design with 6 reps was used, and trials were conducted at 4 locations across Minnesota and North Dakota. Post applications were made to sugar beet at 3 different growth stages, and then this experiment was taken to harvest. So acifluorfen was applied post at the 2-leaf, the 4 to 6 leaf, and the 10 to 12 leaf stages. And then we used 3 different rates, 8 ounces, 16 ounces, and 24 ounces. And then a glyphosate check was included as well. So this trial was kept weed-free throughout the growing season so that we could focus only on the effect that acifluorfen had on sugar beet. And then this table summarizes the results across all 4 locations that we did this year. Ratings for necrosis and growth reduction were taken 7 and 14 days after treatment. Each plot was 6 rows wide, but we treat only the center 4 rows. And so then to evaluate our percent visible necrosis injury, we compare the treated rows in the center to the untreated border rows. And then we'll use a 0 to 100% scale, and 100% meaning that the plot is just completely brown, and visible stature reduction is done the same way, comparing the center rows to the border rows. So necrosis injury was greatest at the earliest application timing, but it decreases as application timing is delayed. Additionally, as you increase the acifluorfen rate, necrosis injury will increase as well. Stature reduction injury decreases application timing was delayed also. And then sugar beet that's sprayed earlier in the season seems to take longer to recover from both necrosis and stature reduction injury. So this would be a close-up of what the necrosis injury that we're talking about. So you can see that the leaf just gets bronzed in here. So this photo was taken 4 days after 16 ounces of acifluorfen was applied to a 12-leaf sugar beet. And like Tom said earlier, this is the stage where you're going to see the most injury for the most part. Okay, so now this image was taken 7 days after 16 ounces of acifluorfen was applied to a 2-leaf sugar beet. So obviously this level of injury is not what we want to start with. And then this is why we would not recommend applying it until sugar beet is further along around the 6-leaf stage. So for reference, these white lines in here show this would be the border row right here. So the white lines are the boundaries of the plot, so you can compare back and forth. Okay, so obviously that last photo is not what we want to see, but then this is the recovery that the sugar beets go through. So again, this is the 16-ounce rate at the 2-leaf stage, but this is after the beets have recovered. Again, with this white line in here, you can see border row versus treated row. So the necrosis level is, it's just super improved. However, you can still see that there's some growth reduction. These beets over here are a little further along than in the plot. Okay, now this image is the 16-ounce rate, but it was applied to 6-leaf sugar beets. And again, this photo is 7 days after treatment, white lines to show you this is the plot where we treated. So you can see necrosis in the beets here. If you look, you can see that browning. And then again, when you compare, there's some stature reduction injury also. Now this image is the 16-ounce rate, so same rate that we've been talking about, but now we didn't apply until the beets were at the 10 to 12 leaf stage. Again, this is the plot here. This would be untreated. Stature reduction is way, way less, but again, if you look, you can see the necrosis injury throughout the plot there. And then this is just a really good comparison of the glyphosate check. So we applied glyphosate at the 2-leaf and the 6-leaf stage, and then this is acifluorfen at the 6-leaf stage. So there's a couple of, you can see there was some necrosis injury that the beets have since recovered from, but otherwise pretty similar across the board here. So that's good. Okay, so now harvest results. So this graph would be sucrose content of the sugar beet at harvest. So these are your treatments down along here, and then obviously percent sugar over here. It's important to note we have some numerical differences. You can see a difference in the bars here, but we did not have any sort of statistical difference. So that means that our early injury did not translate to any significant yield loss. As a matter of fact, here, our 16-ounce rate at the 4 to 6 leaf stage actually had the best sugar content across the whole trial, beating out glyphosate as well. Okay, and so then now here, this would be root yield. So we've got tons per acre on the y-axis this time. Again, no statistical differences here, even though we do have some up and down numerical differences. The 16-ounce rate applied at the 4 to 6 leaf stage, again, just slightly less than the glyphosate check over here. And then finally, recoverable sucrose. So this would be pounds of sugar per acre. And then in this, we did have some statistical differences here. So what that means is if the bars share a letter, then they are not statistically different. But if they don't share a letter, then they are statistically different. So this 4 to 6 leaf stage here, 10 to 12 leaf, even if we bump to the higher rate, they are not statistically different from the glyphosate check. So that's great. All right, so while we did see necrosis and stature reduction injury from acifluorfen, the high rate does cause more stature reduction injury than our 16-ounce standard rate when you apply them to the same growth stage. Acifluorfen should not be applied to sugar beet that is smaller than 6 leaves. Root yield, percent sucrose, and recoverable sucrose measurements were not affected by acifluorfen as compared to the glyphosate check if they were applied to the 4 to 6 leaf stage or later. Okay, so now we're going to talk about control. So the efficacy experiments where we evaluated sugar beet injury and then also water hemp control in response to acifluorfen rate and adjuvant use. Just gonna give you some conclusions about those. Acifluorfen at 8 ounces, 16 ounces, and 24 ounces plus NIS provided 38%, 55%, and 66% visible water hemp control, respectively, 14 days after treatment. Crop oil concentrate, methylated seed oil, or high surfactant methylated oil concentrate with acifluorfen improves water hemp control as compared to NIS with acifluorfen. However, oil-based adjuvants with acifluorfen will increase your sugar beet injury. So then our final objective with these experiments was to evaluate the sugar beet injury and water hemp control when acifluorfen was used in a tank mix, because this is where we see acifluorfen being utilized most likely on the last lay-by application. So these experiments were conducted in fields with known high water hemp populations so that we could evaluate the percent water hemp control as well as the percent sugar beet injury. And then applications here were timed to water hemp height rather than sugar beet leaf stage, and we did not harvest these experiments. Okay, so this table summarizes the results from 3 locations where the experiment was conducted this past summer. So sugar beet injury is a combination of percent visible necrosis injury and percent visible growth reduction. These evaluations were done the same way that I described before. You compare the 4 treated rows to the untreated border rows. Acifluorfen plus glyphosate and NIS resulted in 76% water hemp control as compared to 55% control from acifluorfen alone and 44% control from glyphosate alone. In fact, when both acifluorfen and glyphosate were part of the tank mix, water hemp control improved in all instances. So acifluorfen plus glyphosate plus ethifumicate, 90% control as compared to just acifluorfen and ethifumicate, 86% control. Acifluorfen plus glyphosate plus stinger resulted in 85% control as compared to just acifluorfen and stinger with 75% control. However, again, injury increases when acifluorfen and glyphosate are in the tank together. Okay, so this would be our glyphosate check. This photo taken 2 weeks after the applications were made. Applications here were to 8-leaf sugar beet, and water hemp was roughly 4 to 5 inches tall. The center 4 rows are denoted by these orange lines here. So your plot's in the middle. You can see definitely we've got quite a few water hemp survivors throughout this treatment. Okay, so now this would be acifluorfen just with NIS, 16 ounces, what our standard rate would be. So you can see here, just acifluorfen plus NIS increased control over the glyphosate check that we just previously looked at. Okay, and then this would be acifluorfen, glyphosate, and NIS. Not very many weeds seen in between the rows here, but obviously, once, like I said, when you throw in glyphosate and acifluorfen, you've got some increased injury, this necrosis across the leaves here. And then here we've got acifluorfen, glyphosate, stinger, and NIS. Again, good control. Can't see very many weeds left here, but more necrosis injury and stature reduction as well. And then this would be acifluorfen, glyphosate, ethifumicate, and NIS. This treatment actually provided the best control in this experiment. So you can see pretty clean across the board along in here for being 2 weeks after application. But again, lots of necrosis injury going on, and then stature reduction as well. Okay, and then this is an overhead drone shot, same location that I just was showing, again, 2 weeks after application. This is just a really good way to compare the tank mixtures. So you can see like weed control is better in some plots than others. Can't see there versus a little bit thicker in this treatment. But also injury. See these guys here. The beats are, you can just see a little bit thinner than like when you compare over here or even over in this treatment here. So just really cool to see. So to conclude, tank mixtures with acifluorfen improves water hemp control as compared to acifluorfen alone or as compared to glyphosate. Tank mixtures with glyphosate resulted in the highest levels of control. However, your injury was also greater as herbicides were added to the tank. But this research does indicate that acifluorfen can be a valuable sugar beet herbicide for post-broadleaf control. So the next steps here, there's experiments planned for 2021 with the following objectives. Is acifluorfen safe to sugar beet when it's applied with glyphosate, ethifumicate, and a chlorcetamide herbicide at the 6-leaf program as part of the water hemp control program? So this would be plan A, like making acifluorfen a component of that second lay-by. Then also, trials are going to look at, is acifluorfen safe to sugar beet, and does it contribute to the weed management system by controlling the later emerging water hemp if it's applied after the 6-leaf stage? So this would be plan B, a quote unquote rescue treatment made by itself after the 6 to 8-leaf stage. We will continue to work closely with UPL. They are supporting a Section 3 label. And then as Tom mentioned earlier, there is support for a Section 18 that is being discussed amongst the co-ops. It would most likely be submitted on a county by county basis in Minnesota, North Dakota, and Michigan. But then Western Sugar would also like to utilize our data. So they're interested in a Section 18 as well. Okay, so this is my contact info if you have any other questions that I don't answer today. Otherwise, Mark, David, Cody, Dr. Peters, they all can get a hold of me as well. And then here's your QR code for the CEUs.
So Emma, we have a couple questions here that have come in on the Q&A. First one being, using Cobra on soybeans seems to help reduce white mold. Do you think Ultra Blazer could have a similar effect on CLS in sugar beet?
I do not know the answer to that. Tom also had to leave, so I should mention any questions I don't answer, we can get back him or I. So
the second question, Emma, would be, do you have any disease ratings for Rhizoctonia or Cercospora, or any observations late season after the acifluorfen was applied on the 2-leaf sugar beet stage?
Yeah,
treated?
So we did not see any differences in regards to disease, like nothing in Cercospora control, same thing with Rhizoc, nothing that we could correlate back to the Blazer treatments.
Great. We still have a few more minutes. If there are more questions, please ask them now. As we're working through the acifluorfen, we really need to know what the questions are so we make sure we can get them answered before we actually get a label that we can use, so we have those answers for you. So now's the time. No other questions?
No other questions in the Q&A right now.
All right, if you have more that come up after the meeting, please send them to Mark or myself or anybody on our ag staff or research team. We'll make sure we get them to Emma and or Tom, and we'll get them answered. I guess there's one more question, Mark?
There's one more question. The Q&A is, you may not know this answer quite yet, but will the label be an indemnified label if it were to come through?
Yeah, I don't know the answer to that yet. It's definitely something we're talking any solution that we could come up with for this. That would be Section 18 is at the top, but that does not mean that an indemnified label couldn't be an option if the Section 18 doesn't work.
Great question. Thank you, Emma. We appreciate your time this morning.